Hi, it's Mrs. Cat, and I'm here for another addition to our three levels diagram for compounds. So this will actually be part number 3. We have a little bit to add to this, and you can either add this directly in the space that I'm going to show you that I've got here, just a little bit in the top part of this macroscopic box, or if you can have some other space outside of that box on your page, please use it, because I think I'm going to run out of room. But after doing Unit 4 Worksheet 3, where we're looking at combination of elements to form compounds, we can give a definition for definite and multiple proportions. So that's where we're going to start. And I'm going to try to match my coloring here. We're going to start with definite proportion and we can also call this or composition. Like I said, I think I'm going to run out of space. So that's our definite proportion or composition. And when we define this, we're going to say that a compound has the same ratio of elements by mass. Okay, so this is saying that anytime you have a compound of that particular substance, the ratio of the elements by their masses will always be the same. Okay, it doesn't matter how large or small that sample is, doesn't matter where that sample comes from, the ratio of those elements by mass will be the same. Okay? Now, multiple proportions on the other hand, which is our second thing that we're going to add here, second and final. I'm going to try to fit it in here. It is related, but also is different. Okay? So we are going to say that we have two compounds made from the same elements. We'll have mass ratios of simple whole numbers. Okay, so this would be our comparison of compound A to compound B that we saw in our 4 examples on worksheet 3, right? We had 2 different combinations of carbon and oxygen, right? They gave us 2 different compounds because they had those 2 different ratios. And that wound up to give us ratios that were simple whole numbers to give us the formula for the compound. For example, compound A wound up to be carbon and 1 oxygen, or CO, that's carbon monoxide. Compound B was 1 carbon and 2 oxygens, or carbon dioxide. And we found that with our other compounds as well, they wound up to be simple whole number ratios. We can either have 1 atom or multiple atoms, but we can never have parts of atoms. Okay, but we know that, I just realized I spelled multiple wrong. I realized that when we put these things together, if they're going to be different compounds, they're going to have different mass ratios, but it will still wind up to be whole number ratios. If it is the same compound, no matter what size of the substance or the sample or where it came from, it's always going to have that same mass ratio, and that's definite proportion. Okay, so this is our final addition to our compounds 3 levels diagram. That should wrap us up with this. If you haven't already, it's time to look at percent composition, which is another way of looking at compounds.